What I want to do in this video is just a little bit of practice of converting between the different number systems. So let's just start with a decimal number. So literally just the number 31. And let's see if we can represent that in binary and hexadecimal. So in binary, you always want to think about, since we're doing it in base 2, that's what binary is, what is the largest power of 2 that is divisible into 31? And you might want to visualize those dots like we did in the last video, because you're trying to divide it into kind of the smallest number of, if you view it in the money analogy, of kind of currency, or of kind of different units of currency. So in here, the units of currency, or the units of place value, are the powers of 2. So what's the largest power of 2 that is divisible into this? So 2 to the 5th power, which is 32, is not divisible into this. So 2 to the 4th power, 2 times 2 times 2 times 2, 16 is. So how many 16s are over here? So we have 116. So if we go into, so let me draw it this way. So let me draw the places. This is the 16's place. This is the 8's place. This is the 4's place. This is the 2's place. And this is the 1's place. So we definitely can fit 116 in here. So let me write it this way. This right here is the 16's place. And this is obviously, let me put it in quotes because I just wrote it in base 10. So there's 116 here. And then we're going to have 15 left over. So you're going to have 15 left over. Let me write it this way. So 15 left over. So how many, see, so what's the next largest? 16 obviously doesn't go into this. So what's the next largest power of 2 that goes into 15? Well, 8 goes into 15 once. So you have 1 8. So you have 1 8. Let me just all do it in blue. So you have 1 8. And then if you have 1 8, how much you're going to have left over this 15? You're going to have 7 left over. So then you're going to have 7 left over. And so 8 doesn't go into it. Let's go to the 4s. You're going to have 1 4. And then if you have that 1 4, you now have 3 left over. 3 left. And then we could take out 1 2. So then we'll have 1 left. We'll have 1 left. And that 1, we can just represent it as 1 in the 1's place. So it's literally 1 1 1 1 1 in binary. Now in hexadecimal, what's the largest power of 16 that is divisible into 31? Well, just 16 is. 256 isn't. So 16 goes into 31 one time. So let me make it clear. Here's our 16's place. That's our 16's place. This is our 1's place. So 16 goes into 31 one time. So we have 116. And then you're going to have 15 left over. 15 left over. And you might say, wait, how do I represent 15 in one space over here? But remember, we're dealing with hexadecimal. Hexadecimals have digits, have representations for numbers all the way up through 15. Let me remind you. You can start at 0, 1, you keep going, you go 8, 9. Then for 10 you have A. For 11 you have B. For 12 you have C, D, E, F. F is the equivalent of 15. So if you want to represent 15 ones, you literally just put an F here. So this might not look like a number to you, but in hexadecimal it is. 1F. This is hexadecimal for 31. You have 116 and you have 15 ones. And this is the symbol for 15. Let's do a couple of other examples, and we'll convert between the different number systems. Let me think of a binary number. So let's say I just have 1 1 0 0 0 0 1 1. So this seems pretty complicated, but if we just break it down by the number spaces, it shouldn't be too bad. So we have 1 1. So this is 1. So that you could just call that 1. We have 1 2, right? This is the 2's place now. Actually, let me write the places here. I think that'll help clarify things when we're doing this conversion, or at least as we start. So there's the 1's place, the 2's place, the 4's place, 8's place, 16's, 32nd or 32 place, 64, and then 128. So you have 1 1, which is just 1. You have 1 2, which if we wanted to represent it in base 2, we would write, or a larger base, not base 2, in base 10, or a larger base than binary, you would call that. So that you have, that's 2. Then you have 0 4, 0 8s, 0 16s, 0 32s. You do have 164, and you do have 128. 128. So if you wanted to represent this in decimal, it's going to be 128 plus 64 plus 2 plus 1. So let me add that up. So if we have 128 plus 64 plus 2 plus 1 plus 2 plus 1, you are going to have 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. 1 plus 2 is 3, plus 6 is 9. And then you bring down the 1. So this is this 1, 1, 0, 0, 0, 0, 1, 1 in base 10 in a decimal number system is 195. So how would we write this same number in base 16? In base 16. So the way to think about it, and actually there's a trick to go straight from base 2 to base 16, but I won't do that just yet. But the way to think about it is, let's take, what's the largest power of 16 that goes into 195? 256 doesn't go into it, so 16 is the largest power. So how many times does 16 go into 195? Let's just do the math. 16 goes into 195, goes into 19 once. 1 times 16 is 16. Subtract. You get a 3. Bring down the 5. 16 goes into 35 2 times. 2 times 16 is 32. Then you subtract, you have a remainder of 3. So you have 12 16s plus 3 1s. So let me write it again. 195, you could write this as 12 16s, and then plus 3 1s. Right? 16 goes into 195 12 times. So you have 12 16s, and then you have 3 1s. So in the 16s place, and this might be a little bizarre, but the more practice we get, it'll actually make a lot of sense. In the 16s place, which is right over here, you're going to write 12. But we're going to write 12 using our new digits. We don't want to write base. We want a symbol for it. We don't want to use our base 10 symbols right over here. So let's remind ourselves. A corresponds to 10 in base 10. B corresponds to 1, 1 in base 10, or 11. C is 12. D is 13. E is 14. F is 15. So to represent 12 in base 16, you use C. So you have C 16s, and you have 3 1s. So once again, this looks more like a gate at an airport, but this is actually a number in base 16. C3, this is telling you you have 12. This is a symbol for 12 in base 16. You have 12 16s, because this is the 16s place, and you have 3 1s. 12 16s. And if you multiply 12 times 16, and then you get to 192, you add 3, you get to 195. So hopefully you found that interesting.